PRQ, what we might have to realize is that we need to put, this is actually 8 plus x plus 5. This whole length here needs to be this whole length here. So that should be 8 plus x plus 5. Maybe an easier way to put that would be x plus 13 for that whole length. X plus 13 is there. Then I have a 21. All right, that seems to be the only information I have, but I can realize that for corresponding part-wise, this x plus 13 matches up with this 8. This 21 matches up with this x minus 9. Now, we're trying to find the value of x. Well, this will be the equation I use to set it up. Maybe I call this one my top. Doesn't matter which one we call our top, but let's call this one our top. That means 8 compares to x plus 13, so I have 8 over x plus 13 would equal, so this is my top, so that will be my x minus 9 over 21. Now we do some work. I just want to very quickly do this because you guys can do this multiplication and stuff, but I think you want to get to the factoring portion of it. So all of this would just equal x squared plus 4x minus 117 equals 168. Okay, well, we have x squared. Yes?
Why is it x squared?
Because we're going to have x plus 13 times x minus 9. So if I look at this goes to that, that would be x plus 13 times x minus 9. Binomial times binomial, we'll get x squared plus 4x minus 17 equals 168. Now, in order to solve something that's x squared, you have to have a 0 on the other side. So we're going to go ahead and we're going to subtract 168 from both sides. That will give me x squared plus 4x. And then we'll have a bigger minus. We'll have minus 285. Now we're going to break this apart into two binomials equaling that 0. Well, in order to factor, this is going to be a factor by guessing kind of thing, because I know these first two terms need to multiply to give me this x squared. So we're going to have an x and an x.
Why'd you put 2?
I don't know where 285?
No, like, why'd you put both x's instead of them together?
Well, what's x times x?
2x.
X times x is x squared.
X squared.
X times x gives me x squared. Now, what I need for this last thing is I need two numbers that multiply together to give me negative 285. But when added, give me a positive 4. So your job is basically to take your calculator out and just see what numbers go into 285. So you can make like a whole list of things. You can see if, well, 3 doesn't go into it. I bet you 5 goes into it. So we can do 285 divided by 5 and put those two numbers. If we work long enough, we're going to realize that 19 goes, can 285 divided by 19, can someone do that for me? I know 19 goes into it. 15 times?
15.
All right, so do you see how the difference between 19 and 15 is 4? One of these needs to be negative, the other one needs to be positive. So I'll do a negative 18 and a positive 5. That will give me x equals 19 using the zero product property, or x equals negative 15. X cannot equal a negative 15 because this is geometry. You actually have to be able to build these things. So x equals 19 is our correct answer. Yes?
Why did we get x equals 19?
The zero product property. The zero product property says if a times b equals 0, either a equals 0 or b equals 0. I think this is a good sign that some of us need to look back at our algebra stuff. You might want to look up how to solve something like this. That's beyond the scope of this class, but it is expected that you know this as an Algebra 1 or Algebra 2 student. Yeah, Safar.
Can we go over number 9?
Yeah. Number 9 says do GD over MH. So GD over MH. But I would note, we had a scale factor first, right? What was your scale factor?
503.
Say that one more time.
503.
Oh, I meant Zavar because he's asking it. Sorry. What? You said 5 over 3? It doesn't matter. Do you have 5 over 3 or 3 over 5? You have 3 over 5. So I'm going to go back and I'm going to write this as 3 over 5. So you have 3 over 5, which means that you called the small one your top then, right? Okay. Well, GD over MH. So if I look at GD, GD is right there. Do I know the value? No. And MH is here. But it doesn't matter. It says GD over MH. I know from the scale factor, well, GD comes from my bottom one, so I do need to flip this. So I'm just going to flip this and make this 5 over 3. I know it has to equal that because it has to preserve that ratio. Your job is to realize that that 3 over 5 affects every single side. So if you don't know a missing value, you still know what it has to equal when you simplify it. Okay? All right, anything else? Yeah.
17.
17. Did you have this done?
I finished it like right now.
Oh, okay, like right now?
Yeah.
I'm going to take a picture of the answer key because you should have had time to look it up, I guess. Number 19, you said? Or 17?
17.
I'm just going to take a very quick picture. We should have had things circled. We should have realized that AB is congruent to DC. So we could have, that's where I'm going to come up with my scale factor. Maybe I'll triangle that. Those are all my corresponding parts. I'm also going to realize if this is 90 and this is 30, this would have to be 60 because 60 plus 30 plus 90 equals 180. That will give me my Z value is 60 because B and E must be congruent to each other based upon this statement here. To find our missing sides, we need a scale factor. Well, I'm going to call this my top, so I'll call it 6 over 21, which does reduce to 2 over 7, but you can leave it as 6 over 21. Now our job is just to take that 6 over 21. Well, that's going to equal our 10 over y and our x over 28. So we'll see I have that 2 over 7 equals x over 28. And also have that 2 over 7 equals 10 over y. Okay? And then just solve this. Okay. All right, we got to get going. We're way, way, way behind. All right. So, do you guys have a theorem of postulate sheet for this section?
No.
No, you don't. Don't shake. I mean, you can shake your head yes, but I never handed one to you. So maybe you have one. I didn't hand one out. These need to be memorized. All right? I gave you tons of stuff for theorem. I'm only asking you to memorize 3 things. And those are similar triangle similarities. Do not confuse these with triangle congruency ones. These are similar triangle ones. These prove that 2 triangles are similar. You have 3 different ways to show that triangles are similar. Angle, angle. You just need to show that 2 angles are congruent between 2 triangles and they are similar by angle, angle. Side, side, side. If all corresponding sides are proportional. Notice it doesn't say anything about congruence. They need to be proportional. Then the triangles are similar. And finally, side, angle, side. If 2 corresponding sides are proportional and the included angle is congruent. So angles are always congruent. Sides are always proportional in order to do similarity statements. So we should probably have these bolded so we understand that stuff. All right, so now if I have to show that triangles are congruent, it's either angle, angle, side, 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 or side, angle, side. For angle, I just need to show two angles are congruent. So if we look at example 1, 75 is equal to 75. 31 is congruent to 31. I don't have to find that next side. I can just say, oh, they are congruent by angle similarity. Now note the thing we need to have on there, the similarity. So I don't see side and think you're proving it congruent. We're going to put that little similarity after it. I just need to show that two angles are in fact congruent between each other. All right, our next one. We need to show that two angles are in fact congruent. I have one of them up there. Is there a second one up there?
Yes.
Where is it?
The angles.
Don't say x and x. A lot of you lost points on the test by saying x and x. I see multiple x angles up there. I see this angle x. I see this angle x. I see this angle x. I'll see this angle x. If you do that on the December assessment, you'll lose even more points. You have to pick 3 letters. Yeah?
Would be like WXY, WXV.
WXV, which would be that one.
YXV.
And YXV. See how I know exactly what he's talking about by using 3 letters? He said WXV, I know where to put those. I know YXZ, I know where to put those. If you tell me x is equal to x, I have no idea what you're talking about. There's so many angles up there. So this would be by vertical angles, and so we can use angle similarity. For side, we just need to notice which ones are corresponding. So I'm going to put my circles and boxes and triangles around stuff. Yes?
Angle similarity, would they like normally be connected together?
I don't know why so many people are talking. Yeah.
Would they like be, because they could like together, the second one, does that kind of mean that's angle similarity?
No, we just, if I can show two angles are congruent between the two, it's angle.
Oh, okay.
If I can show two are congruent, if I can put these symbols on there, they're congruent by angle. It's just if you can make those symbols, they are angle. Okay? All right, our next one, do you see any angles marked? No, so I must be using side. So to use side, locate your corresponding sides. So I'll do something like 3/6 should equal 4/8, needs to equal 5/10. Is that true all the way across the board?
Yes.
Grant, do you mind picking up your head? Dan, do you mind picking up your head? So what's 3/6 reduced to? 1/2. 4/8? 5/10? So this works. So we go yes. And this would be by side. Notice the little squiggly mark I put after because it's a similarity statement. All right. I don't have any marks on this, so we just have to assume it's drawn in the correct position. So I'm going to circle the 30 and the 24. I'll put a box around the 35 and the 28. I'll put a triangle across here. I didn't do this on the other one, but I should tell which is my top and which is my bottom. So we're going to have 30/24 needs to equal 35/28 equals 32/25. Are all of those equal? And if you're not sure, just plug them in your calculator. Type in 30 divided by 24, and then type in 35/28, and then do 32/25. Are all those equal? No. This is false. So not similar. So we definitely can't do a similarity statement. All right, our last thing is side angle side. Side angle side I need to show that they're proportional sidewise and that the angles are in fact congruent. So we would still circle sides. So I'll circle 8 and 6. I'll box in 20 and 15. Do we have an angle that's congruent? Yes. Do those sides flank that angle? Yeah, that angle is definitely included. So we might be able to use side angle side, but we do need to check that 8/6, so I'll call this my top. I do have to make sure that 8/6 equals 20/15. That is true. So we would use the side angle side similarity statement, and we're good. On our very last one, we need to realize that we have two triangles here. We have this small triangle here, and maybe in pink I'll do the big triangle here. I should note by the reflexive property that A is included in both of those. So by the reflexive property, I do have an angle, and I do have sides flanking it. So I'm looking at 15 would compare to 25. This 12 would go with this 21. So we do have side angle side, but I got to first make sure they're proportional. So I can do like 15 over 25 equals 12 over 21. Do those look equal to each other? Nah. That's nope. So these are not similar. Santiago.
Do you need to add the square line?
Yes. I said that's very important to this section because I don't want congruent. I don't want to see side angle side and think you're proving something's congruent. I need to know you're doing the similarity statement. All right. Now we don't know which one we're supposed to use, but there's always a good sign of which one we're going to use. How many angles do we have here?
One.
We do have three angles. I asked a horrible question. There are three angles in all the triangles. How many do we know are congruent between the two?
One.
We know one. Do we have sides labeled that are flanking that one angle? Yes. Our job is to assume that they must have just rotated this a little bit, where if I rotate it back, this 5 would go with this 9, and this 3 would go with this 15. So I might be able to use side angle side. Don't just make the marks and go with side angle side. You have to check to make sure it works. I'm going to call the small one my top, which means 5 over 9 must equal, 3 over 15. Does that work? Hang on.
I thought 5.
That's false. Let's just stop for a second. Yes. Let's assume that maybe it wasn't just rotated. Maybe this 3 goes to this 9, and maybe this 5 goes to this 15. So this first one didn't work, but let's try this next one. Let's try 3 over 9 equals 5 over 15. So my first thought was wrong that they just rotated. Maybe they flipped it instead of rotating it. Is 3 over 9 equal to 5 over 15? That is true. True leads me to be able to go at side angle side similarity. So we do have to check multiple different ways. Yeah. It doesn't matter which one's your top or bottom. But you need to understand that for similar triangles, I might have just turned it, or I might have actually flipped it. You have to find out what the corresponding sides are. It doesn't matter which is your top and bottom. You just have to know which ones are your corresponding sides. So my first thought was 3 went to 15 and 5 went to 9. That's not true. It turned out it was 3 went to 9 and 5 went to 15. So we do sometimes have to check twice. If the first way doesn't work, try the second way. All right, our next one. Do we have any angles? No. Now, here's the nice thing about this. We know it could be similar, but we have to line things up correctly. I got to get the corresponding sides correctly. Now, do we have all three sides listed? Yes. I'm going to pick the biggest side on here, which is 35. Let's call this our top. 35, that's my biggest side. What's our biggest side on the other one? 25. Our middle side would be 28 and 20. Our smallest side would be 22 and 16. So I'm organizing from biggest to smallest. For the scale factor to work, our biggest must match up with our biggest. Our smallest must match up with our smallest. So once again, these are my two largest sides. So that means if that's my top, I need to have 35 over 25 would have to equal 28 over 20, which would have to equal 22 over 16. In fact, this is the only way it would work. Either that statement's true or I don't need to check anymore. Is that statement true, though? Should we check it?
Yeah.
All right. What is 35 over 25 reduced to? Because 5 goes into both of them, so we have 7 over 5. What goes into 28 and also goes into 20?
4.
4. How many times does 4 go into 27? 7 times. How many times does 4 go into 20? 22?
No. 7 doesn't really.
7 doesn't go into 22. So we could reduce this down to 11 over 8. Is that a true statement all the way across the board? Nope. Not similar. Yeah, Santiago.
So it has to be the biggest number to the smallest.
Has to be biggest to smallest, mid to mid, small to small. Has to for it to work. All right, our last one on this page. So I know that this one is 42 degrees. How do I find a missing angle?
180 minus.
Yeah, 180 minus everything else. I like that. 180 minus everything else. So 180 minus 53 minus 42. Can someone do that for me?
95.
Oh, I don't know. I got 85 and I got 95.
95 is 53 plus 42.
105.
It's 105 now? Now we have 105.
It's 80.
I was thinking 53 plus 42.
85.
It is 85. It is 85. Double check with your calculator always. Well, now I know that this is 85. I have an 85 over there. I have a 42. I have a 42. I don't have to go any further. This is just angle, angle, similarity. What time does this class end? We have 50, 55, might be 50. Let's do 2 more together, and I'm just going to release you on your homework. So I did want you to have a bunch of time to work. Yes?
Did you also say with the vertical angles?
I did use vertical angles.
Oh,
I had to use vertical angles to figure that's 42.
so you can't go. You can't do
Yeah.
80.
Yeah. What was that?
You can't say just because like 85. 85.
Well, I use vertical angles to say these are both 42. That's where I use the vertical angles. That's the only time I use vertical angles. All right. A couple more together. So I'm going to look at this one. Our potential triangles are the small one and the big one. To get the big one, I do have to know this entire length. So I'd go, oh, that's 20. This would be 6 plus 18, which would be 24. So we would need this 18 to match up with this 24. I would need this 15 to match up with this 20. And I'd also need this 12 to match up with this 16. I will tell you, you could shortcut this one. Do we know a shared angle between the two?
That's why.
Oh, XY is not an angle.
XPY.
XPY would be an angle that they share between each other. So we might just have to check 2 of the sides. We don't have to check the third one. If those 2 flanking it work, then we're good and we can use side angle side. So you could use side, side, side on this one, or you could look for side angle side. I think proportions are the hardest part. Angles are pretty easy to see if they're congruent. So I'm going to look for side angle side. So that means I'm looking at, does 18 over 24 equal 15 over 20? Does that work?
Yes.
What goes into 18 and 24? 6 goes into both of those. So that'd be 3/4. 5 goes into both of those. 3 over 4. We're good. We can use side, angle, side. I should put the similarity after it. Now note you could have did side, side, side by just checking 12 over 16 would have worked as well. So you could have did side, 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 or side, angle, side. All right, one more. I just wanted to get to this one because I do like parallel lines. People always forget how to use, yes.
Wait, why did we not use 12 over 16?
Why didn't I use 12? I said we could have.
Oh,
I noticed that I had an angle, so I could either look for side, angle, side, or I could have looked for side, side, side. If you're doing side, 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 you would have to do that 12 over 16. All right, for the last one, parallel lines. You're looking for alternate interior corresponding angles. A lot of us need to look at this because a whole lot of us got this wrong on the test. Not a whole lot of us. It was just the people that did just train wreck on these. Parallel lines create corresponding or alternate interior angles. Well, in this case, I'm going to use corresponding angles. I can put a tick mark here and a tick mark here. Look at the next pair of parallel lines. And I can put a double angle mark on there. And that's all I need because this would be angle, angle, similarity. All right, that's enough. That's enough of this. We just kind of